So what we want to do, so are we saying we did not do 7b and c? Is that what we're saying? All right. So we want to get into this because I want to do the division one as well. So this is going to be bang, bang, bang. So let's have a look. 7b. Did we do A? We did. I think we did A. We didn't. We did. Thank you. Yes. So 7A. Oh, did we? Well, let's not do 7B again. Maybe you just did it. Did you do C? A sailor went to sea to see what he could see. But all that he could see was the bottom of the deep blue sea. Okay. So we've got the example just sort of sitting there that you can semi-follow along. But this is how we do it. Right, if a sequence is defined, t, the first term is 2. And then t, n, so the n plus 1th term is this. Then we could say the rule is tn equals that. And that's what we want to try and prove. And the basics of our induction is the same. So we're going to start with, what's the first thing that we have to do? Prove P of 1 is true. So we're going to look at P of 1. Now that means we've got T1 equals 2. And then what we're trying to do is here, we take our T nth term and we make N1. So we go 1 equals 2 to the 2 take 1 all over 1 factorial. Do you see what we've done? We've just subbed in. So n is 1. We've popped n is 1 in here, and we want to show that it will indeed equal this. So 2 take 1 is 1. 1 factorial is 1. And so it does indeed equal 2. And we can say, therefore, P of 1 is true. Nothing there is new. What comes next after we say P1 is true? All right, we do that whole, let's assume, or let PK be true. So that's what we say here. So we're going to say, assume or let PK be true. And so what that means is we're saying TK equals 2 to the 2 take K all over K factorial. We're assuming that's true. Agreed? Again, nothing to actually do. You're just making a statement and you're saying that it's true. What is it that we now wish to do? Prove PK plus 1 is true. Now, this is where I sort of add this in, and the book doesn't do it that way, but I like to do it. I actually like to put down what it is I'm trying to do. So we want to prove PK plus 1 is true. In other words, what we're trying to show is that TK plus 1 equals 2 to the 2 minus K plus 1 all over K plus 1 factorial. Agreed? Now, I hate doing this, but I'm doing it so I don't have to go down too long. I hate having two equal signs on the same line, so try and refrain from doing that. So let's simplify this. This becomes 2. 2 minus 1 is 1 minus K all over K plus 1 factorial. Do we agree? Have I done anything amok? Check. Maybe I have intentionally. Here comes the proof. So we go back to our statement and we actually have this. So we want to prove that this k plus 1 is indeed equal to this statement here. Yeah? So what is it? Tk plus 1. So tk plus 1 equals, what does it equal? You could read it out to me, but no. Tk over, thank you, Sam, k plus 1. Okay? And we go, right, well, what is tk? Right, we're assuming that this t, the kth term, right, we're assuming is this. We're assuming that that's true. Agreed? We slap it in. We go, that's 2 to the 2 take k all over k factorial. But we're also dividing by this. How do we do that? You just sit it downstairs. Remember from first principles? Yes? You just sit it down here. So that's 2k plus 1. Do we agree? Digest that. We've substituted in tk here. We've put that here. So technically that is 2 to the 2 take k over k factorial, and I'm dividing by 2 k plus 1. That's what this is saying here. Correct? But we know that when I divide, I turn that into a times and I flip this to become times 1 over. So that's why that's sitting downstairs. We all good? And we're trying to make this look like this. We're nearly there. Why are we nearly there? Come on, guys. 1 take k. Why can I say, yeah, this is definitely 2 to the 1 take k. Why? Yes? Yes? Am I or am I not dividing by the same base here? 2 take k over 2 to the 1. And when I'm dividing by the same base, what do? You take the power, so you get 2 take k, take 1, and what does that equal? 2 take 1 is 1, take k. Bingo, bango, bob. Yes? So that becomes 2 to the 1 take k. Now, we should actually show that. So I'm actually going to say 2 take k over 2 to the 1. Right? Otherwise, if you just go, oh yeah, equals, how do I know you actually have done it? You're not just fudging it. So that, and then that's, what am I left with? K factorial times k plus 1. So this becomes 2 to the 2 take k, take 1. What do I want the denominator to be, please, Liam? K plus 1 factorial. Now I've got k factorial times k plus 1. That is k plus 1 factorial. Why? Think about it. Yes, it's timesing the next term. So remember, if I've got 5 factorial, which is 1 times 2 times 3 times 4 times 5, and then I'm timesing by 6, isn't that then 6 factorial? Yeah. And if I've got 8 factorial, this is 1 times 2 times 3 times 4 times 5. Why did I choose 8? Times 6 times 7 times 8. And so then if I times it by the next term, that's times 9. Is that not now 9 factorial? So you've got k factorial, and then you're timesing it by its next term. So that is indeed k plus 1 factorial. Therefore, p k plus 1 is true, and write your little statement. Right, so here we go. And nothing new, Bobs. We do the same thing. We start with, let's proving the first term. So we want to prove P1 when n equals 1. So we've got T1 equals 1, and then we're going to pop 1 into this one. And we go right minus 1. 1 take 1 is 0. Times 1 times 2 all over 2. Anything to the power of 0 is 1. 1 times 2 is 2. 2 divided by 2 is 1. Therefore, P of 1 is true. Yep. Right, the next one, we go, yeah. We want to assume or let PK be true. Yeah. And I'm trying to break it up. I could say assume PK is true. Or what did they say? If PK is true, then, right? You don't have to have the exact same words, but the general gist of. So, let PK be true. So we're saying that TK equals minus 1 to the n take 1. Oh, I always do that. So I put the K there. K take 1, K plus 1 over 2. And this is the step that the book does not do, but I strongly recommend that you do it. Okay, we say we want to prove K plus 1 is true. Yeah? So what are we trying to prove? We're trying to prove that it's minus 1. Now K plus 1 take 1 is K. Agreed? K plus 1? K plus 2. All over 2. So that's what we are trying to prove. Here comes the proof. We hope. So what is, from our statement, K plus 1 term? It's this thing here. Yeah? So I write that down. I go TK plus 1 equals now TK plus minus 1 to the K. I feel like I'm going to do it in white. Don't ask me why. So what do I do now? I've got this. What do I do next? Excellent. Substitute your TK in there. Okay? So that's the bit that we were assuming was true over here. So we're going to substitute this TK in here. Here we go. This becomes minus 1. K, take 1. K plus 1 all over 2. And we've got this plus minus 1k, k plus 1 squared. Now what? So I'll just pause while you guys make sure you've got it down so you can have a look. And what was the technique we did when we had fractions? We wanted to. Yeah, and this one is all over 2, so we go, okay, let's make this over 2. So we can do that really easily, but we go, okay, that's the 2, and then we just times it by 2. I'd love to put the 2there, it would be a bit squishy, so I'm just popping the 2 there. Because in effect, 2 divided by 2, it's just 1, I haven't done anything illegal. Next, I don't want to expand. I'm looking. Look at what you're meant to prove. And I go, I want to pull out a common factor. Now, my heart starts to beat a little bit faster. Why? Because look here, k plus 1. Look at here. Wow! I've got a k plus 1 here, and yes, Bobby, I've got a k plus 1 there. Ooh, looking good. This thing here, though, this thing is being a bit of a pain. Minus 1 times k. So I've got a minus 1 to the k here, but this is a minus 1 to the k take 1. If only it was minus 1 to the k. You can split it apart. Now, do you agree? Minus 1 to the k take 1. That is the same as minus 1 to the k times minus 1 to the minus 1. Now, if that was any other number, when it's got a negative power, it goes downstairs. But what's minus 1 to the minus 1? 1 over minus 1, which is minus 1. It's just that is just minus 1. Put it in your calculator if you don't believe me. So this now, I can rewrite this as minus 1. I'll put them, do you want me to put the minus 1 there or not? Okay. K, oops. So it's minus 1 times minus 1 to the k times k plus 1, plus minus 1 to the k plus 1 squared times 2. And I know you're thinking, this doesn't look very nice. But it's always darkest before the dawn. Here comes our common factor. And if you don't think this is fantastic, I'm going to change my name. So here we go. Minus 1 to the k plus 1. When I pull that out, what am I left with? Negative k goes in the bracket. Have you done this? Right? Now, that's gone, and that's gone. So what's now left here? It's a plus. K plus 1 times 2. So you're happy if I go 2k plus 2 all over 2. That's a funny bracket, right? Keep an eye on the prize. What is it that you're trying to prove? What have we got? We've got that. We've got that. Or I really hope that this ends up being k plus 2. Does it, Bronte? Yes! Minus k plus 2k is 1k. It's k. It works, Annie. How good does it feel? I feel good. Da, na, na, na. I knew that I would. I feel good. Now, with question 8 and 9, if you notice, they have given you T1, they've given you n plus 1, but they haven't actually given you the rule. They haven't said what Tn is, and you have to actually find it. And we find that, and I saw that, Samara, that was an eye roll of huge proportions from Samara. So we've got T1 equals 1. We now are going to work it out for T2. So how do we find T2? That's going to be T1 plus, so to get T2, n is now 1, correct? So 2 times 1 is 2, plus 1 is 3. What was T1? 1. So 1 plus 3, we get 4. Happy with that? What's now T3? Well, according to this rule, that will now be T2 plus 2 times 2 is 4 plus 1 is 5. You right there, Nick? So that becomes 4 plus 5 is 9. I love that Sam just said, I'm beginning to see a pattern. Well, that's the whole deal. You actually have to tell me what the pattern is. So this now becomes 9 plus, I should have written, sorry, T3 plus 2 3s are 6 plus 1 is 7. So I get 9 plus 7. Now, if you don't see the pattern, you probably have to keep on going. But this is when n is 1. So n is 1, I get 1. When n is 2, I get 4. When n is 3, I get 3. Aha! When n is 4, I get 16. So, from looking at that, we can say, therefore, the nth term is n squared. So you've now got your rule, and you're going to do what we've just done before. Does that make sense? And you will do the same thing for number 9. We're now going to do a divisibility one. What's up, Nick? Yeah, hurry up. So, instead of go hand in hand, we want to prove that this is divisible by 3. So no longer is it this plus this plus this plus this equals this rule. It's, can I prove that this statement, for any value of n greater than or equal to 0, it will always be divisible by 3. Guess what? Same system applies. We first prove now, do we prove P1 this time? No, because it's saying n is greater than or equal to 0. So the first term we're doing is prove that P0 is true. Yeah? So we slap 0 in here. What's 4 to the power of 0? 1 plus 2 is 3. Is that divisible by 3? Is indeed. Therefore, P of 0 is true. First term is true. Wake up, Bobby. What do we then do? We assume PK is true. So we're going to say, I'm assuming that this thing is divisible by 3. How do I write that? Well, I say that statement equals 3 times A, where A is any integer, any whole number greater than or equal to 1. Would you agree? 3 times anything. If I get an answer of, I don't know, 3 times 10, 30. Hey, that's divisible by 3. 3 times 7, 21. Oh my God, that's divisible by 3. So, happy with that statement? Happy with that statement? We then go, okay, so we now want to prove pk plus 1 is true. So we stick a k plus 1 up here, plus 2, and we have to try and prove that this is divisible by 3. Look what they've done. Are we happy? Who can explain to me how they've gone from here to here? They split them, because when I'm timesing by the same base, I add the powers, so k plus 1 is the same as 4 times 4 to the k. We good? What we now do is we go, oh, hang on. 4 to the k here, I can rearrange that and say it's 3a take 2, and that's what we've slapped in here. 4 times 3a is 12a, 4 times 2 is 8, still got the plus 2. Put them together. Oh my God, I can pull out a common factor of 3. And therefore, it's divisible by 3. Done. That's how we do it. Do you think it's not easy? It's different, but let's now put this into practice. I think you will like this. They're debating with me. Okay. Now we're leaving the binomial expansion. If we have a bit of time, we can come back and do it. All right. So, by mathematical induction, put a little heading. Divisibility induction. Bronte, don't talk while I am, please. I know I don't stop, but I've got limited time. So, exercise 16, 6C, and we're looking at divisibility. All right, now, for starters, we're trying to get out of the habit because every question we've done so far is the first term was P1. this one, because it's n is greater than or equal to 0, we're going with, we want to prove that P naught is true for P of 0. So we go 3 to the 0 plus 1. 1 plus 1 is 2. That is divisible by 2. Therefore, P0 true. Nice. Next. What was the next step? Come on, we got this. Okay, so we assume PK true. So in other words, we're assuming that 3 to the k plus 1 is divisible by 2. So that means it's going to equal 2a, where a is any integer and it's greater than or equal to 1. The next bit comes to prove P k plus 1 is divisible by 3. So we're looking at 3 k plus, thank you, that would have been embarrassing, k plus 1 plus 1. And the idea, remember, every single time with this PMI, we want to try and use our PK. So, I want to try and use this. The problem is, I don't have just 3k. I've got 3 to the k plus 1. How do I get just a 3 to the k? Split it. So this becomes 3 times 3 to the k plus 1. And then I'm going to substitute. And it's like, you might not have thought to have done that, but that's what the example had suggested, and now it's just the same thing over and over again. So what will I sub in for 3 to the k? 3 to the k equals 2a, take 1. Now I've got the plus 1. We expand the brackets. And what I'm hoping is that you should be able to pull out a common factor of 2. What's the matter? Come on. 3 times 2a is 6a. 3 times minus 1 is minus 3 plus 1. And lo and behold, 2, 3a take 1. Therefore, it's divisible by 2. And you put your statement. I can't say this enough. Statement is the same. You don't have to remember a new one. But please notice, you do have to put this little la 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 where the thing in the bracket is an integer and therefore it is divisible by 2 or by 3 or whatever. So please make sure that you do put that in and then put the statement. I'm being very brief on the board because we want to try and expose you to as many of these questions as we possibly can. Okay.